Good evening. Thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. We're excited to bring to you a look into the digital SAT and how your students using the TI-84 can be successful on that exam. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make those really tough to teach and tough to learn concepts accessible to all my students. And with us tonight, we have Scott Knapp and Pat Flynn. Pat's been teaching math for over 30 years. He's currently teaching AP Calculus BC at Olathe West High School in Kansas. Pat's a 2013 Presidential Award winner for excellence in math and science teaching. He served on TI-Nspire authoring teams, was a writer for the We All Use Math Every Day program, which was in conjunction with the television show Numbers. It was a great show if you happen to catch it. Pat's has presented at many international, national, regional conferences, lots of different areas, technology, calculus, algebra, geometry. Currently, his passion is helping his daughter as she takes college algebra this year. So, Pat, good luck to both of you. And it's great to have you with us.
Thanks, Mike.
And Scott has been teaching math for well over 20 years and currently teaches Algebra 2 and AP Calculus AB at Glenbrook High School in Illinois, which is a suburb of Chicago. Scott has served as an AP Calculus reader and has been a TCube regional instructor since 2011, has led numerous workshops on TI-Nspire graphic calculator, as well as served on authoring teams for both TI-Nspire and TI-84 professional development. Scott enjoys presenting sessions at local, regional, and national conferences as well on how to use technology to support students' success in learning mathematics. So, Scott, it's great to have you with us.
Thank you, Mike. Welcome, everybody.
Typically, we get to our agenda and our expected outcomes, but that's actually in Scott and Pat's slide deck. So I'm going to hold off on that and just talk about that we're going to be using that chat window tonight to send general messages. It's on the lower right side of your screen. As a reminder, this session is being recorded, and we'll provide a link to that certificate of attendance at the conclusion of the webinar, along with a link of the documents as well. And then later on, Pat is going to be showing kind of like some questions as well as the calculator. And if you need like that zoomed at all, or any of the sizing changed, if you notice kind of the top middle of your screen right now, it's underneath Pat's icon for me. There's a little plus minus, and you can adjust the percentage in case you need to zoom in, zoom out, and make things a little bit easier for you to see. With that being said, I think, Pat, you're going to share your screen and we'll be ready to go.
Fantastic. Oh, here we go. Okay. All right, well, here we are. We are leveraging the TI-84 for student success on the digital SAT. Scott and I were both really lucky to spend a lot of time on this and create some materials that we think will help your students out, especially when they get stuck, right, Scott? Like, we really want them to do the math, but man, when they get stuck, we got some good tips to help them out.
And this is a high stakes test, so it might be a little bit different than what you talk to your students about for your own tests in your math class. This is the test that might determine whether or not they get into a certain college. So we want to have them equipped with the best skills coming in with the technology, but as well as just some good strategies. So you'll see that both of those today. So our expected outcomes, our first one is we want you to be able to leverage the technology, the TI-84, effectively. And so your students can be as successful as possible on the upcoming SAT tests. And we also want, we were hoping you leave with an idea of a couple of strategies that you can use to help motivate your students in class. It's always good to kind of know what you can do to help push them along for these high stakes tests.
Yeah, and some of these will be brand new to some of you, may not even thought of these ideas before. So it should be pretty great for all of us.
So the way that we're going to structure tonight is we're going to first of all start off with what is the digital SAT, because many folks may not be familiar with the format, how things have changed a little bit. We want to make sure that you're up to date on that because there are definitely some nuances and differences. And then after we've gone through that part, we're going to show you some strategies. And there were, I think, 3 that we ended up talking, just test taking strategies to help motivate your students along. And then we'll kind of switch gears to using technology and some of the things that you may or may not know that the calculator can do that will help support a student on the SAT test. Okay. And like Mike showed with the chat, please, especially this beginning part, if you have questions, please send them through the chat. I know that Mike and Pat will both be monitoring it. We may not know the answers necessarily. We don't write the test and we're not, from the SAT group, but we can do our best to try to answer those. And Pat and I have done this presentation before, and this is often the early part here where we talk about the test itself, where there are quite a lot of questions just that people just need to know answers to. Okay. So as far as some things to know is that, it's now digital. So students will need to be prepared for that. They will need to bring a fully charged computer or laptop device. You are allowed to request one from College Board. I'm not exactly sure how that works, but they would provide you with one. And they need to have the Blue Book app installed on their device. And that's something that they need to really come in having prepared for, and that might be something new to them.
And this is the same Blue Book app that you can use for like PSAT and AP exams and all of that, I think.
Yeah, they're all coming through that same portal, but they'll need to have that downloaded. Definitely to bring a pen or pencil for scratch work. Obviously, all of the responses are going to be through the digital platform. And to bring a calculator, we definitely encourage students to show up with a calculator. Whatever they're using in your classroom is probably their best piece of technology to use on one of these tests. So, and all of the TI calculators are available to be used on the test, the 84, the Nspire, and including the Nspire CAS.
And the big difference on the digital is it's not one section, it's calculator. It's like the whole math test, right? The whole thing they can use the calculator on, which is a big change for them.
Yeah. And then the question and answer service, Pat, go into this a little bit more.
Yeah, so it used to be when students would take the SAT, about a month or 2 later, they would get sent their scores. And then they would also be able to get like a copy of their test, right? And the answers to the questions and which questions were deemed more difficult or less difficult. I think there was a score of level like easy, medium, and hard. And in fact, some of the questions that were tossed out that were used for piloting purposes. Well, now that's not available anymore because, as Scott and I are going to talk about, the test is adaptive. So there's not really like, here's the one test that you took. There's a lot of versions of the test out there. And so they will not be able to share it with you. Now, what they have said, and they did this last year, is they shared on the Blue Book app some practice tests. So as a teacher, install the Blue Book app onto your computer, pull up some sample questions. They're supposed to be releasing them. I've not checked this year, but they're supposed to be releasing like a new practice test every year on that Blue Book app. So that's how you can get them now. So it's no longer the paper. Very, very different from what it used to be. And then the timing, right, Scott? I mean, the timing is such a big difference from what
it is a huge difference. I think when you look overall, per question, it's only a 15-second difference. But it used to be 1 minute and 35 seconds, and now we're down to, we used to be 1 minute 20 seconds. We have more time. It's an advantage. We have 1 minute and 35 seconds. I don't think that the way they ask questions has changed much. And then as far as the question types go, 75% of the questions are multiple choice. And so that's 33 of the 44 total questions. And then 25% are what we call student produced response, where they have to grid in their answers. And to the right, there is just kind of the generic way they show you how you can grid in a number like 2/3. And so that there is a little bit of difference to that. Now on the test, it will explain how to do that, but it certainly would be an advantage to your students to maybe practice that or just know how to answer those questions best, because it is a little bit different, when you have to grid in an answer versus just circling A, B, C, or D.
Right. And then the Blue Book app, you want to talk about this, Scott, the different features?
Yeah, if we have time at the end, I have the Blue Book app installed on my computer, and I'll run through some of these different features. But these are what we think of as the main features that students could use. There's a geometry formula sheet they have access to at all times. There's a way for them to eliminate answers in case they're not sure. If it's between like B and C, they can cross out A and D on the screen. They can mark a question for review so that it's easier to know they can have a question that they still want to come back to. The nice thing, there's a timer right on their computer that will tell them their current time, what's left of their test. There's a question menu that allows you to kind of toggle between questions quickly. And then there is a digital calculator drop down in the Blue Book.
And then the actual, like if you load it up, here's what one of the questions looks like, right? You can see where you can flag it on the top left. There's
Yeah, and then you see where you can do the cross out of the answers. That's to the right. If you would click, we can't click on that because this isn't the actual Blue Book. But if you click on the right where it shows a slash through the response, that would knock the response out. And so it would help students focus on the remaining responses that they were more confident in.
Yeah, and
if we do have time, yeah, we'll try to pop this up and show you a little bit more.
Yeah, so like we talked earlier, to say adaptive test versus a linear, right? The old one was like everyone takes the same test, questions 1 to the end, you go through. What they're doing now is they're changing it. There's not just one path through the questions anywhere. There's a couple different paths. And again, the test wouldn't change, right? No matter how well the kid's doing or how poorly they're doing, the test is the same for them. But the adaptive, right? It's a bit different. It's 2 stages. And if I remember right, I think everyone has the same first stage, right, Scott? The first module is the same for everyone.
Yeah, everyone will take the first 22 questions. And then from there, it will be determined whether or not they advance to the more difficult or the easier version of the second half of the test.
Now, it doesn't say like, and then when the kids get to the second part, it doesn't say this is the hard section. They don't know. They don't know if they've got the hard or easy one. So
yeah, it doesn't inform them of that.
But do notice the number of questions they're taking, very different amount than it used to be. It's a lot less questions that the kids take. In fact, it's a shorter exam, right? It's like Scott alluded to this, the per question, not so much, but the overall time. I mean, look at that. It's over an hour less.
Yeah, over an hour less. So those of you who, like me, might have to help administer the SAT, that's our state, or it was our state test. We're switching to ACT, but I've had to administer that in the past. There's just such a shorter test. And then the amount of time per question, we talked about that, and fewer questions. And this is one thing I learned, I think, during the pandemic when I was trying to make my assessments as short as possible based on the learning environment we're in. We can assess students on a much less amount of questions and probably find out just as much. And so I like that we're creating that environment for them where there's less fatigue and more focus as they take the test. And then I think the next slide is a quote actually from somebody on the CEO board. 97% of students are finishing the test with up to a certain amount of time to spare. And so I think it's great that these high stakes tests, the majority of students are finishing them on time. And so that's a better measure of probably, comparison between students, which is what the standardized test is doing.
Right. And then there's, even in terms of the word count, there's less than 50 words per question, mostly. 30% of them are in context, in other words, word problems. And then 70% are like just pure math questions, right? The ones we might see in our classroom. So in class, I know you too, Scott, we do both of those in class. And they
the one thing that I like to tell students, though, is don't be intimidated, because they have shortened the word problems, but 50 words, that's a lot of words still. And so there are going to be times where they have to really look through. But a lot of times what I've found is the more words doesn't make the more difficult problem. Right. As far as the math goes, it's the more difficult of, processing those words and what is it that I need to accomplish here. And that takes some skill and practice for sure.
Right. And then the order is still the same in general, that the questions get harder as you go through the 2 separate modules. And in fact, and speaking of the modules, well, actually, this is a nice comparison Scott put together of the traditional versus the digital SAT. And then the PSATs in there too that the kids take in the fall. But,
yeah, and I generally just look at the first and third column here because I don't work with students that my students do, before they see me, take the digital PSAT. But one thing that really pops out at me is that geometry is more heavily covered here, and data analysis and problem solving is quite a bit reduced, in fact, by half. So, it looks like the old traditional SAT was just over 60% algebra and advanced math, algebra 2 sorts of things. Now it's about 70. So there has been a little bit of shift in the topics and how heavily they're weighted on the test.
Right. And in terms of the two modules themselves, this is kind of the way they weight it out. I mean, everyone's taking the same first module, everyone that takes the test, and that's worth over half of their score. And then, like Scott said earlier, depending how they're doing on that first module, if they're doing really, really well, they're going to get the second module that's more difficult. That second module is worth 5/12, so a little bit less than half of it. And I think we've actually got some breakdowns. Yeah, we have some breakdowns of like scoring, right?
Yeah, and one of the questions that came in was if a student with hard questions punished because of that? And that's a great question. So I think if you take a look here, the cutoff is, I believe it's 14 out of the 22 will get you into the more difficult section. So if in module 1 you get 14 or more correct right answers, you will take the more difficult module. And so if you take a look, the first row on the left, where a student only got 13 right in the first module, they just missed that cutoff, but they got everything right in the second module, they finished out with a 540. But if you look at the student who, we could go down to the bottom 2 rows, who barely got in, with a 14 or 15, and even if you didn't get any correct, they still ended up with a pretty decent score. Now, that's probably not a scenario that happens too often, where they get 15 right on the first one and none on the second, but certainly it's not going to penalize them for taking the more difficult module.
Yeah, it's like a predictive, right? They're trying to okay, it's like almost like 2 sieves, like trying to separate the students out. And if you did really well in first module, we'll give you access to get to those tougher questions and get a much higher score. But like Scott showed you, you still can get a high score doing the easier second module still. So yeah.
All right. Well, it seems like we've talked about the test a little bit.
Yeah.
Again, if more questions come in, I've been trying to read them, and most of them were questions we were just about to answer, but I think we got to most of them. Why don't we do some math?
Yeah, here we go. Our first technique. Again, we want to emphasize, we really want students doing math, right? Doing the mathematics. But, kids get stuck. They're like, gosh, what do I do? It's a high stakes test. I freeze up. Like Scott said, we want these kids to score as well as they can so they can qualify for as much scholarship money and get into all the schools they want to. And our first one is substituting numbers. And they pick numbers. Numbers are much easier than variables. And the only thing with this technique is we want to stay away from 0 and 1. So kind of the way we're going to go through these is we're going to show a question, which you see right here. And then we're going to go through right. It's got a traditional way of solving it. And then we're going to show the technique of hey, what do you think about this idea? How do you think?
Yeah, and I think with the traditional way, that might be taking longer than a minute. And I think it was 10 seconds, right? I've already forgotten how long each question is. Or a minute and 35 seconds. It might take them longer to do it than that. So maybe the strategy will get them there quicker and or more, accurately too.
Yeah. So in math class, we'll start off what we're given, and we're just going to try to modify this to make this look like 8b over a. So do reciprocal on both sides, multiply both sides by 8, and we get an answer of 2. And that's the traditional way, right? The answer is letter B. But the technique way, right, is pick values. So let's use that strategy. Let's pick, whatever values we pick, like we said, it's got to be true. So whatever I pick for A and B, I've got to make sure when I divide those, I get 4. So A is 8 and B is 2. So now let's plug it into our problem. 8B divided by A, we get the answer of 2. Pretty quick. Not involving reciprocals, a lot of heavy-duty algebra. Plug in some values, make sure the values make the equation true. That's the big deal. And then we get our result.
Yeah, and again, we're going to see a strategy that's similar of substituting in 0 or 1. But if you notice, this is something rational. And so we want to definitely steer away from 0 or 1 here, since division by 0 is undefined.
Right. And then some of these questions get even more complex, right? Gosh, I can imagine the kid taking this test and going, oh my, I've never seen this in math class. What do I do? And we're like, well, traditionally we'll take what we're given, substitute into Z or Y values, and simplifies up. Then, of course, you got to factor it, right? That's your traditional way. But this
That's a
technique
lot.
of,
That's a lot of steps, right?
yeah,
And then to the factoring is probably the hardest part, I think, there at the end for
oh,
most
yeah.
students.
And how about you? Like with my students, I always make them factor out a 2, and it just, uh,
And
it's crazy.
that would be equivalent, but not what
Yeah,
we're looking for here.
right. So let's pick some values that work. Now you've got to make sure it works. So if I decide to let A equal 2 and B equal 3, well, that means we'd have 4 plus 9. So Z must be 13. Like Z has to be 13 based on what we did for A and B. And if A is 2 and B is 3, then AB is equal to 6. So the Y value is equal to 6. So we've got all of our variables figured out. Not too bad. Kids are pretty good with that. And then we're like, well, what is 4Z minus 8Y? Turns out the answer is 4. So we're looking for something that has an answer of 4. So we start plugging in our values for A and B. And I can imagine it's got a lot of students probably be plugging them in using their calculator on this.
Yeah, real quick
And
calculations.
yeah, and the answer is B. Now, the one thing we do want to encourage students, if you're using this technique, you do want to go through all the choices, right? You want to make sure. And I think we're going to hit that a little bit later with the zeros and ones, but you want to check them all to make sure.
You might have picked a combination of numbers that would have actually had 2 different answers in the list.
Yeah.
So yeah, you got to kind of check them all.
Okay, so here's one. In the equation A subtract B divided by A equals C. A is positive, B is negative. Which must be true? Well, gosh, the traditional way, right? We got to remember that subtracting a negative really means a positive, and a positive plus a positive is a positive, and a positive. There's a lot of vocab in that, Scott, going through it.
Yeah, for sure.
Strategy, though, so much cleaner. Again, we said stay away from zeros and ones. Like Scott said, dividing by zero is not such a good idea. So we picked a value for A and a value for B, and we said A was positive and B was negative. So you got to make sure the B value pick is negative. And we plug the values in. We see our minus there, 2.5. Oh gosh, which answer would that be? That would be letter A. 2.5 is definitely greater than 1.
One thing I noticed looking at a lot of SAT, there's a lot of variables in these situations and relationships and things. And I probably, this is a great strategy, I think, for students, because you're actually using real numbers that match those things, and it can help them be crafty to get to the answer. And they're still doing math, I think, when they do that, right?
Oh, they are. They're definitely. And especially, these questions, no numbers at all, right? I mean, the whole darn thing.
So bring numbers into it, because
Yeah.
variables are just numbers that have not exposed themselves yet.
So here's one, right? It's a really nice question. Again, A is positive, so whatever we pick for A better be positive. Which he's following is equivalent. And then there's one strategy we always like kids looking at is glancing at the answers. And as a math teacher, we can see lots of different forms of the question going on here. It looks like it's some factoring, and of course, this is a difference of squares question, right? And if you know the math, really fast to get there. If you don't, though, man, try the strategy. Let's pick a value for A and a value for X. And given those two values, we can figure out what Y should equal is -5. So we're going to look for on the left-hand side, which of these gives us an answer of -5. Well, plugging in our values for X and Y, we're like, that can't be it. This can't be it. That one can't be it either. The answer is B. Now we're kind of going through to get the right answer at the end so you can see them all, but obviously a kid would check A, then B, then C, then D. But again, they need to do all these, right? They can't just do, oh, the answer is B and move on. They need to check all 4 of those to make sure.
Yeah, and some of them they might be able to toss out quickly. I just saw the last one, 2 plus 9 squared.
Yeah.
That's going to be way too big, right? And so
not even close. Okay, so now here's the 0 and 1. So the first one we saw was just picking values, staying away from 0 and 1. But now, Scott, we want them to use the 0 and 1.
Yeah, this is situations that are not rational.
Right.
But that a lot of times what questions on the SAT are looking for is, and I love this because I think it's important for us as teachers to bring this up in our classes, equivalent expressions. We want things to be equivalent. So they should be equivalent for the same numbers that you plug in, no matter what those numbers are. Now, if they're rational, then we've got some, possible discrepancies to that. But plugging in a number like 0 or 1 doesn't take a lot of work. In fact, a lot of students can do that in their head, and that might lead them to the equivalent expression when the math might be a little bit more cumbersome.
All right, so here's our first one. Not too bad, right? Distribute that negative across and combine like terms. In the blue, there's our answer. Not too bad. But again, like this technique of 0 and 1, really pretty nice. If x equals 0, our original problem at the top of the screen, answers 2. We can calculate that very quickly because multiplying by 0, right? It really cancels out a lot of things. And then when you start putting zeros in for all the answers here, we actually see that there are, well, 1 in this
No,
case.
there's just one.
Just
Yeah,
one.
they're all in standard form. So I like that we have shown the plugging in of 0,
Yeah.
but students, hopefully we think at this point that if they're putting in something 0 into something that's a standard form, that constant at the end is what they're looking for. So that could make this really quick.
Absolutely.
Okay? And Pat, I think you were thinking that this one was the last one. So
this is the one. Yeah. So if we do the 0 and 1 idea again, now of course we see, if we glance at the answers, the math teacher Scott and I are like, oh yeah, it's completing the square, of course. Kid that gets stuck, they're like, complete what? Well, this would be the math that they would have to do. And of course they wind up with the correct answer. But using that strategy, right? Do 0 first. In our problem at the top of the screen, the answer is 15. So we're like, well, which one of these would give us an answer of 15? Well, there's actually 2 of them, right? 2 of these give us it. So this is what happens, right, with that 0 and 1. You tried out 0. We got it down to 2 choices left. Repeat that with x equaling 1. If x equals 1, our original problem is 24. So we're looking for which one of these would give us an answer of 24 when we put 1 in for x. And of course, the answer is letter B. It's kind of like a double check, right? You got to go through it twice, but it's 0 is pretty fast.
You used your quickest number to plug in, which is 0. Your next quickest option would be a 1, unless you're looking at maybe -4 or +4 would be good choices here for the answers, but that would be a little bit more work for the original. So 0 and 1 are always good go-tos for this.
Yeah, I had a student, and we were doing some test prep. We were kind of discussing. I'm on my 4th snow day right now of school, but before, when we were still in school, I was doing this technique with my students, and they're like, Mr. Flynn, this is like solving an algebra question without doing the algebra. I'm like, yeah, when you're stuck, I've got this one kid, I was telling him about it. He's at a 13 on the ACT, which is a different test, obviously. And we're trying to get him up to like a 20. And we're looking for all strategies possible. He really, really liked this 0 and 1 strategy. It was so great.
And I don't think that they're not doing math when they do that. They're still establishing equivalence and that relationship. And that's something we don't talk enough about. Even some of our students who are best at factoring or best at the algebraic structures may not really realize what they've created when they simplify that algebraic structure. So it almost to me is just as good of math as knowing the structure. Both would be better.
Yeah. So here's a nice one, right? Rational, right? And well, again, the old way of doing, the way I would do it in class, good old long division. Kids love
after factoring's not going to work. Yeah, then. But what student likes to do long division?
Yeah.
My calculus students
this week
for this. My calculus students last week were, throwing garbage at me after I said we might have to do some long division to be able to integrate what was left.
Yeah.
So yeah, it's a tough thing for students if they're not in the groove of doing it for a while.
Right. Now you'll notice we had said, like, in a rational expression, try to stay from 0s and 1s, but you'll notice when we use a 0 and 1, we're not dividing by 0 in this case. So we're safe using the 0 and 1 in this case here. And, put a 0 into the original problem, we have -3.5. So very quickly, like Scott said, change all the x's to 0s. And I think we've got 2 different answers that have a -3.5. So repeat the strategy with a 1, right? And the answer is letter D. Again, pretty quick, right? Again, we want the kids doing that long division, but this is a really good strategy. It's a really good one.
Somebody brought up synthetic division. It is in play here because we're dividing by a linear factor. What I found though last week with my calculus class and is that the chances are if they didn't remember long division, they didn't exactly remember how synthetic division worked, because it is, synthetic. It's faking the process.
Right.
So, students need to figure out which one they might want to latch onto if they're going to actually divide the polynomials.
Well, and under a clock, right? You've got only so much time to figure out what you want to do on this question also.
Yeah, I would rather spend time teaching my students this strategy that we're showing you than reviewing long division for the purposes of doing well on the SAT.
Test. Yeah, exactly. All right. So another one of substituting values in is ordered pairs, right? So again, we'll substitute values, but we'll just do it a little differently. In this case, what's the value of A? Okay, gosh, what could A be? There's a lot of ways to go about this, right? But the quick way is to plug a 2 in for the X and a 4 in for the Y value. And now it becomes just a linear problem to solve. A is 4. Right? I mean, you could go through other strategies there, and I'm seeing in the chat like lots of ways to do things, and those are the great problems, right, Scott? Where there's multiple ways, and I think at the end of our PowerPoint, you've got one problem where we're going to show a lot of different techniques to get to the right answer. So
yeah.
Okay, so here's again, solve this system of equations. Pretty generic, like you see this in math class all the time, and okay, I'll multiply the bottom equation by 4 and go through it. But I'm always amazed the kids that still have trouble with this. Like,
yeah, and then also I see this switcheroo a lot on the SAT, switching the variables. They're not lined up, right?
Yeah.
In one equation, X is coming first, and in another, Y is coming first.
Yeah. So easy to make that mistake. So you got to make sure you're plugging in the values, and it's got to work in both, right? So we're just going to take each answer. So letter A, X is 4, Y is 1, doesn't work in both of them. We try letter B, those answers don't work. We try letter C, it does work, but again, just to make sure, we tried letter D and nope, doesn't work, that's it. Now there are other ways to solve this, but using this technique that we're talking about is plugging in values. Okay, did you want to talk about so I originally didn't want to do structure, and Scott's like, we got to do structure.
We've got to do this.
Big deal.
And again, keyword of the day for me here, equivalence. And I love that SAT is using these types of problems, and it's really kind of neat. And your kids, they will like looking at things like this. I gave some to my Algebra 2 class last year, right before they were taking the SAT, and they, after a couple of them, they started looking for these patterns and looking for equivalence. And it was a very powerful exercise, not just for the SAT. But sometimes there will be problems where we can do a lot of algebra, but if we're really mindful and paying attention to the original structure of the problem, we might see some structure in it that we can use to find the right answer. So let's look at a couple examples of that so that you understand what I mean. So in this situation, we've got a quadratic equation and we want the value of the quadratic expression. So most folks would probably think, well, I got to find X. So let's see what that looks like.
Right, and using technology, we could feel like factoring it. We could find the intercepts, and
I don't think we can factor this one because I don't think that those are rational zeros to begin with. So I don't think it factors, which probably would have been our first attempt, right?
Quadratic.
Second attempt, we go to the calculator and we can store those, but I don't know that we're going to necessarily we'll get reasonably close to the answer, right? But this looks like it's a grid-in problem because we don't even have answer choices. But if we take a step back and look at x squared minus 5x, it's very similar in structure to 2x squared minus 10x. And so let's take a look at what happens. Well, first of all, I always tell students, the equation will have the same solutions if we divide a common number off of both sides. And so if you ever see that, reduce that equation down, make it just a little bit easier to work with. And now we see that common structure in there. And remember, we're not trying to find out what x is. We're trying to find out what x squared minus 5x is. And so we have x squared minus 5x in front of us. And if we just bump that 8 over, that's the value of 8.
Okay? Yeah, and aren't the kids amazed at like, wait, I don't need to figure out what x is? And you're like, no, you don't need to figure out what x is.
Yeah, exactly. And
Yeah,
so it's
so
avoiding
again,
all of that algebra, but seeing that equivalent structure.
yeah, so like Scott said, we see that x squared minus 5x, we're trying to find out what that is. That's kind of like the big key. Hey, this is a structure question. So here's
Yeah.
another one, right?
Yeah, so this one, absolute value equation, I mean, students, again, it's a little bit of a niche topic in Algebra 1, maybe a little in Algebra 2. They may not remember how to solve for x in these situations. So let's see what we've got here on the slide.
Yeah. So again, making use of structure,
We're
we
looking
will,
for that structure in the equation. So if we factor the 5 out, it's a positive, so that's not going to impact the solutions. And divide it off, now we have absolute value of x minus 1 equals 17.
and then notice on this, SAT does this a lot, like what's the positive value? What's the negative value? What's the sum of the, you got to pay attention to what's going on here. And since we only want the positive answer, we are going to say x minus 1 equals 7, right? We'll say the absolute value of x minus 1 is a positive 17, not a negative 17, because we're looking at the positive value.
Yeah.
Yeah.
No, we might have one more here.
I think we have one more.
Jump to some technology.
This one's kind of reverse, isn't it? Like we're trying to figure out what the 30 minus 6x is, but
this is not a difficult equation to solve, but I have a lot of students who might, maybe don't like to dig in and do the math and get the pencil to the paper, but they can notice that if I multiply the left side by 6, I've got 30 plus 6x, 6 times 7, 42, done. I'm moving on. And if they've seen a few of them like this, they could become really quick at these. And I don't, Pat, do you remember when we analyzed the tests?
yeah.
It seemed like there were, I don't know, up to maybe 5 situations per test that would have something like this.
We were surprised as we went through, like, wait a minute, this, hey, here's another. I mean, it was a big shock to us, really, of all these ones, because I didn't even think it was a type of making use of structure was even on the test at all. It was quite surprising when we did this a couple of years back.
And again, I like the way the test is developed, because it's really finding out what students have some command of algebra, whether they can dig in and factor and do all those great things we want them to be able to do, or if they can think and maybe be more efficient.
Yeah, and I think, if someone's solving for x and plugging in is not thinking as deep as using this use of structure question, for sure.
Yeah.
Well, now I think we've got some tools, right?
We've got some technology here to go. Yeah. And these are a couple of tools that I wasn't so familiar with until I started digging into the SAT a little bit more. So I think they could be really helpful for folks. We'll look at the simultaneous equation solver and then something called the numeric solver.
Right. So here's that question that we saw earlier, right?
Yep, that system of equations.
So we're going to solve this using the simultaneous equation solver app. So everyone at home should get their calculator out, right? And I've kind of got mine down here. And to get to this, right? To get to this, you have to press the apps button, right, Scott? The AP.
Yes, it's in the apps.
And it's right by that math button, right?
Yeah. And number 9, poly simultaneous too. Yeah. Not sure why they call it that,
limited to how many characters they can call it, probably back in the day. But it does a lot of stuff, right? And we're going to be talking about the second one. But if this is a new app to you, you might want to come back and investigate this a little bit and see some other things that you can do. Yeah. But we're going to deal with choice number 2. Okay, so now we have to put in like how many equations we have. I think we have 2 equations. And what we do is we can use the arrow keys to maneuver around to different places. Like if I had, instead of 2 equations, 3, I would just press the enter button to select 3, right? That's how I know. But it's 2, so I'm going to make sure on the 2 I've pressed enter. We like decimal answers. Degree radian really doesn't matter in this case, right? Because there's no trig involved. And what we want to do next is hit this next button. And I can't remember the name of these. Are these the function keys or fat keys?
Yeah, I think they're the function keys up there. So you really want to hit the graph key.
Right. Press the button directly underneath the next button, which would be graph. And now we actually type in the values, right? And again, like Scott pointed out earlier, they were in the wrong order, right, on the problem. So, and to move around, you type in the number, you press enter, and it jumps to the next piece. Now, this is a plus sign, so I'll press enter again to move to the next piece. and 7. Now for this one, I think it's -1, right? And we got to make sure to use the
Yep.
negative sign, not
Yeah,
the
negative, not
positive sign.
minus.
Right. And then we are adding our 2y. So again, I'm just pressing enter to move from cell to cell to cell.
Okay.
Okay, I got them all typed in. And I always tell my students, you know, there's a chance you could press the button wrong. So just go back and look, make sure all the numbers are right. And it looks like we're good to go. So what do we do next? Can we press the solve button?
I think so.
Yeah, okay, so that'd be the graph button right below the word solve. And when we solve it out, we get a, boy, maybe I typed something in wrong, Scott. That doesn't seem right, does it? Let's go back. Let's go back to main.
Yeah, I think, what did we have wrong? I was
Yeah.
watching you do it.
Yeah, okay. So simultaneous equation solver, graph, 3x plus 4y equals, oh, I see it. Anyone else see it?
Oh, yeah, you didn't change the -8.
Yeah, I
That was
think
there
it
to a -9.
Oh, I think what happened, this is it. So I had typed in the -9, but did not
Did
press
not hit
the
enter.
key. So again, make sure you see them in the top of the screen. Yep, it's there.
There we
Okay,
go.
well, hey, unplanned moment, but
Let's learn
hey, we
from
got
it.
the answer. 5 -2.
There we go.
Pretty quick, right? All right. So let's see here. Now to get out of this, right? So this is a deep app. We want this main button on the far left-hand side is the y equals key, right? We're going to press that, and then we're going to come all the way down to number 6, which says quit the application. That's kind of how you get out of that screen. Otherwise, you're like, how do I get out? What's going on here with this?
Okay,
Oh,
so that's the simultaneous.
Yeah, Marilyn asked if we use that app in class, and I'm like, yeah, I do. I use it because on my exams, I really believe in a calculator portion of the exam, and then, like I should say, technology portion of the exam and non-technology part of the exam.
Yeah.
And yeah, I might have them solve this 3 different ways. Show me all the different ways to solve this, and that's a very rich question you can do in your class. But for us, again, we're trying to focus on the SAT, right, Scott? That's what we're kind of here for.
Yeah, absolutely. Absolutely. And I just had this experience last week in pre-calculus. We were doing some work with vectors, and we were dealing with some forces and ended up with a system of equations with cosines and sines and the variables. And that's where I would jump to an app like this, where, okay, we know how to solve a system, or we could review that, but the quick solving is more important than all of the manipulation that we would have had to go through. So yeah,
And
something that I would
then the
reserve
one
for those
thing
situations.
we've put on here is screenshots of all the pieces as we go by, because I believe they get a PDF of all this, and in that way you've got your nice notes. It's like, hey, what are all the screens we go through? We've got those on there for you all, so when you're at home trying to go through this, remembering what we did.
Yeah, you should be able to follow our trail.
Yeah. So the next one is solve this, find one solution. So again, this is like a gridded, right? So there's 2 answers, but they only need to give one of them. So we hope they would do factoring, right? Or complete, well, if the kid was using some kind of technology cheater like photomath, it would be completing the square. But there's lots of ways to solve this. We want to show you a thing called the numeric solver, and this is one of those hidden things. No one's aware of it, it seems.
We couldn't see it on the PowerPoint because the calculator was covering it. So go ahead and hit.
Sorry.
No, that's okay. If you hit, well, now you can see it, but I was going to say, just let's point it out when you press math here in just a second.
Oh, yeah. So yeah, so we press the math button, and then we've got to scroll all the way to the bottom, but there's a nice shortcut. If you don't feel like scrolling to the bottom, if you're at the very top, just press the up arrow and it brings you to the bottom of the list, right? But at the very bottom is numeric solver. Now, I saw in the chat a few people said they didn't see some things. That means your calculator needs to get updated, and I think Mike has sent out a couple some help on how to update your calculator, right, when his session's over. But if you don't see numeric solver on yours, you really want to get the update, because this is it's a game changer. It's really pretty slick, and it's so applicable to a lot of questions. So not too hard. What we do is we just type in, we pretend the E1 is equation 1. That's the left-hand side of the equal sign. And then equation 2, E2, is the right-hand side. So I'm going to type in the left-hand side, which is x squared plus 10x minus 24. Okay, so that's my left-hand side. And then press the enter key. And now the right-hand side is 0. I'll be okay with 2 zeros, but there's this word okay here. So I'm going to press the word graph because that's right directly beneath the okay button. And it wants to solve this, right? And so I'm going to go ahead and I have to give it a starting value to solve at. So I might just type in a number 2. Could be anything, right? And what it does, Scott, if I remember right, it finds the answer closest to that number.
Correct. Yeah. So, we see this and we know that, and in this case, the question is, what is one solution? So we don't have to worry too much about it, but let's see what comes out when we have x equals 2.
Yeah. 2.
Oh, and it came out with 2 because, well,
so let's try a different one. Let's try like say
Yeah.
-5, right?
So the other solution is going to be what? -12, I think. So yeah, you're going to have to pick something a little bit closer to that.
Maybe -18. That would be definitely closer. Yeah, there we go.
And then we get the -12.
Yeah.
So yeah, that is something that you got to play around a little bit with and know the nature of your solution, so to speak.
Yeah. And what's nice about this numeric solver is that you can put in, now, again, we're trying to pick something very simple to go through. There's a lot of people in the chat, there's a quicker way to do it. Yes, on this one, there is. But there's some other questions that we're going to show you that are like, okay, I think numeric solver might be the way to go on this one.
Yeah, there's always more than one way to do something on a calculator, right? And so it's good to know what all the different tools you have. It might not be what you specifically would use for each situation, but it's good to know that these are there.
Okay, so here's one, right? We're trying to solve this equation. This one's a little more involved. But if I press the up arrow to get back on top of E1, I can type E1 in. Now it's a fraction, right? So there's 2 ways to get the fraction. One way is to press alpha and y equals and choose the first choice, numerator over denominator. Or on the 84 plus CE, it's kind of cool if you go alpha and then the variable key. Either way, we can type in the left-hand side, which is 55 over x plus 6. And then for equation number 2, x. So I've got my left-hand side typed in. I've got my right-hand side typed in. I'm going to go ahead and press the graph button below the OK. Yeah, I'm going to leave it as -12. That's fine. Press the enter key. Oh, hold on a second here. Let's try, press solve, sorry. And we get -11.
Yeah, which isn't positive. So I don't know that I would have started with -12. Maybe,
Right.
Something positive.
Yeah, so maybe 1. And again, if we happen to notice, we can change boundaries and so on, but you've got to be on that x equals to have that solve button appear at the bottom. And we get an answer of 5. Now there's that decimal point of 1 at the end. That's an artifact of the solving method that's used.
The algorithm, yeah.
Yeah. So cool. So that one, a little more interesting on that. We've got another one too.
We've got about, I don't know, 7 more minutes. Maybe we
oh
can
my
jump
gosh.
to
Yeah, we got to get going.
looking at graphs and tables a little bit and maybe do one example of each of those.
Right. Now, so we have all these ones in here that you guys can look through. Scott and I were just talking at the beginning that we've got way more than we go through. So tables, here we go, Scott.
I think tables is a good one to look at.
Yeah. Okay. So if we want to solve this, the traditional way is to set them equal to each other and get it equal to 0, factor it, equals 0, trouble. A lot of things going on here with the kid, right? But tables are kind of an interesting way to do this one, right? So we go to, what is it? We go to, first we got to go second quit to get out of here. We have to go to y equals and type these 2 things in, right? 2x squared. Okay, so I've got them both typed in. And Scott, how do we get the table then?
We've got to go up to the menu where it says second graph. Yeah, I can't quite see it on my screen. I thought it was there. Okay.
And so we're
And
just, yeah.
Yeah, and the way we have our table set up right now, it's depending on what we just did the last time we graphed, it's got the x values that are in there. So we're trying to find where the y1 and y2 are equal. And so let's see. And the problem here is if, and this is a grid in, we don't have the answer choices to look at. But
Right.
just a quick scroll down gives us.
Yeah, when X is 4, they both give an answer of 31. Nice.
So let's look at another one now.
Yeah,
go ahead
absolutely.
and forward to the next one.
Yeah. Here we go. This one.
This one, yeah.
Yeah. So algebraically, kind of rough. Like what?
Students struggle with radicals and powers. But if we do some graphing, so let's go ahead and put those into y equals.
Right. And the other one is just an X.
And then this time we have the choices in front of us. So let's change the table settings.
Right.
We're going to press second window.
Right.
And instead of having the independent variable automatically being decided for us, starting at -6 and jumping by ones, let's change it to ask, because then we get to call the shots and we get to make the choices for what we fill into the table, because we don't need anything but when x is -2, 0, 2, or 4 to answer the question.
Right, and you can see we just got that by pressing enter on the ask. Now, if we go to table, second graph, everything's gone, but it's ask, right? So we just type in the choices. Like if I typed in a 4, 2, well, it looks like they're working for everything, Scott. We're supposed to find the one that doesn't work.
That's right.
-2.
That's the -2, because as we all know, the square root of x squared isn't x, it's the absolute value of x, right? And
correct.
Most students struggle with that idea. And so this is a strategy that might help them out.
And I think we got another table after this also for them to see. And again, there's the screenshots for when you all get the PDF to kind of see all the steps. Okay, so here's one, right? Which of these functions would be this table for? What would f of x be? Mathematically, we kind of like them finding the rate of change first, right? So we know the rate of change must be 3, which we're inclined to go with letter B, but just to confirm that the y-intercept is 6, we pick a point and plug the values in, and sure enough, the answer is 6. But like Scott said, right, the table, it might be a way for a kid to see, like you talked, like multiple representations, right, different ways to see the math. Maybe the table would be a better way for someone to kind of really explore what's going on. So I think I've got to go ahead and type in all these equations, right?
Yeah, that's the drawback.
Kids are so fast at this, though.
They are much quicker than we are, for sure. And especially on a computer versus the handheld's much quicker to type these things in.
Right. The X, there is no button for the.
Yeah.
And then 5x. Okay, so I got them all in there, Scott, and we go to the table.
And we want to make sure we enter numbers that are from our table.
Right.
So let's see what we've got.
Let me go back to that previous screen so we all can see those. Okay, so X is
1, 3, and 5.
1, 3, and 5. 1, 3, 5.
And the only table that has the same numbers,
right,
or the only row.
Right. 9, 15, 21. Looks like Y2 gives us 9, 15, 21.
Yep.
That's what we're looking for. So Y2, which was 3x plus 6. Again, there's a lot of ways to get to some of these answers. We're just trying to point out some nice technology ways of getting there. And I think some people here know some even faster ways to do some things too, some ways that we may not have even thought of before. Yeah, there's one right there talking about some different ideas.
Yeah, there's always so many different ideas, and especially for our students taking these tests, the more ideas we can try to give them, maybe they can latch on to one or the other and lead them to a little bit more success.
I think we got time for that one question that we did a variety of ways of solving.
Yeah, we did one at the very end that kind of took a lot of our different methods.
Right. So truth
Um,
statements, take a look at these at home. Pretty great way to see if things work out. The big key on the calculator is, what was this? Got a 0 means the problem was false, and a
it
1
means the
means
equation, it's not balanced, it's not true. If it returns a 1, then that means it was a true statement. Exactly.
right. So here's a question that, well, not that one. Let's get to, here we go. So this one, we've got a variety of ways of solving. So at home, think of like, try to think of a couple different ways that you might go about solving this one, right? Besides the standard mathematics, got to solve it. Because, I mean, kids on this one, especially the standard math, they always get worried when all those X's cancel out. Like, what do I do?
Or did I make a mistake? Yeah.
Yeah. So one way could be to actually graph it, right? You could graph the left-hand side and the right-hand side. And notice, whoa, the lines are parallel. That means there's no solution. And that's a pretty deep level of learning on that, right? It's not just, rote memory, like, oh, parallel lines, they're not intersecting means there's no solution. Kind of nice. I think another way we had this was using the table that you just talked about, Scott.
Yeah, exactly.
Putting the left-hand side and the right side in, and again, using that ask so we can type in.
Yeah, I would
zeros.
I would probably tell my students to have their table set for the independent variable to be asked before a standardized test.
Right. And we notice none of these work, right? No solution. And even that truth statements that we kind of skipped over a bit, but truth statements, we type in with a 0 for all the X's and we get a false statement, 0. All those numbers give us zeros for results, meaning, like you said, it's not an equivalent statement on both sides of the equal sign.
So those are not solutions.
Yeah. There's a lot of great stuff on here. And again, I think we could do this for hours and hours of all these different techniques and spend some time on it. But hopefully we've kind of gotten some people some ideas going, some different ways to think about giving kids successful methods of doing well on an SAT.
Yeah, hopefully you know a little bit more about the new SAT, as well as how to use the calculator and some of the strategies that we have showed to help prepare your students.
Yes. All right, Michael, I think we're about right there. Yeah. Right. So perfect.
Hey, Pat, if you could do me one favor, I know that in April you're going to be co-hosting a YouTube Live SAT TI-84, but it's weird because it's on YouTube Live. It's on a Thursday night, I think. What's different about it? Like what?
Well, we're doing one for ACT and then a separate one for SAT, like you mentioned, and it's going to be live. So I mean, it's Jeff McCullough's doing it, and like my daughter told me, my face is made for radio, so I'm not sure how the YouTube Live's going to go, but we're putting together kind of like things from this PowerPoint, but a lot of other ideas that we want to kind of go through with kids that have trouble, and then the students. Like this session here is for teachers, right? Like I'd be surprised if we saw a couple students on. Though it'd be great if we had some students on this, but the YouTube Live is just for students, so teachers can watch too. And the students are going to submit questions, and then we're going to go through and answer them. We'll have some pre-made things already, but they'll be asked like, "Hey, how do I solve this kind of problem?" I'm like, "Oh, great! Here's some nice techniques on the calculator for either the Nspire or the 84 and how to solve this." So it'll be pretty exciting. I'm kind of curious how it goes. Yeah, YouTube Live. It'll be they're trying to go for about 4,000 or 5,000 people on at once. So the chat will be quite quick, I'm guessing. But they're gonna do giveaways and stuff, and I think the host of this show is this it's this guy in Chicago, Scott, that does the Math in the Wild. He teaches geometry and construction. Like he'll walk by a set of stairs and quickly measure the rise and run and do the inverse tangent to calculate the angle and measure it. He's kind of hosting it. So
okay, I need to meet this man.
Interesting. Yeah, he seems like a good dude. I like the class, geometry and construction. I mean, you build things and you see if it's right or not.
Right.
So anyway, it'll be interesting. Hopefully people will go to that. And I know they're going to send out, once they have the links and everything set up, it'll be like, I think if you signed up for this, everyone's gonna be starting to get emails from TI about stuff, and I'm confident it's gonna be in one of those for sure.
Awesome. Thanks so much. So we are giving away to one lucky winner a TI graphing calculator of their choice. Tonight's lucky winner is Linda Strunk. So Linda, congratulations. I'll be reaching out to you over email, most likely tomorrow, to get some information about which calculator you'd like to receive. Speaking of receiving, those documents which we promised, along with a link for the certificate, is in the chat window. I'm going to repost that real quick. And if you're having trouble with these links for any reason, just hang tight. You'll automatically get a follow-up email within a couple of days with those links, as well as a link to the recording as well. And if you're watching this on demand, copy it, link it to your favorite browser to receive your certificate. Huge thanks to Scott and Pat for everything they put together for tonight. Really appreciate it. Thanks for the documents. Thanks for all the tips.
Hey, you're welcome.
Yeah,
Best of luck.
thank you. You're welcome.
And thanks everyone for joining us tonight. We hope to see you back online next week. Next week, we're going to be talking about recipes for pie. So I'm still learning as to what we're going to be doing next week, but it's sure to be great. So have a great night, and we'll see you soon.